Okay, in this video we're going to look at what it means to classify systems of equations in terms of their solutions, as well as how to solve a system by using the substitution method. So first, we have to be able to classify solutions. Now, to classify them, we have two categories, and you essentially choose one from each category to classify completely. Your first category is what we call consistent or inconsistent, and the way we classify is based on the solutions that we determined or we received in the problem. So here we have consistent means that you found one solution or infinitely many. Inconsistent means no solutions. So you're going to look at the type of solution your system has, and then you're going to classify it by selecting the appropriate label out of the category. Now, the second category is called independent-dependent. So in order to be dependent, you had to find infinitely many solutions. Independent means you found one or no solutions. So for example, if you found that your system had infinite solutions, so that is the key, infinite solutions, then your answer would state infinite solutions, consistent, and dependent. Okay, so notice we're talking about the type of solution we had and then its proper label, one from each category. So when you're solving systems, it's a really good habit to be in that every time you get a solution, you practice classifying it. Usually you don't have to classify your solution unless you are asked. So pay very close attention to what you're being asked in the problems you're doing. Now, the substitution method is the method used when you have integers or fractions. So if your systems have fractions, then the substitution method is the method that you would want to choose to use because it's going to be a little bit easier. It's also the perfect method if one of your variables has no coefficients. Okay? The substitution method is very simple. You're going to choose one of your equations to start with, and you're going to solve for a variable. Most students choose to solve for x, so hence the note solve for x, but you could solve for whichever variable you wanted. You're then going to take what you just reduced down, and you're going to substitute that new equation into the other equation from your system. So what you're setting up is like a leapfrog action, where you're going to leap back and forth from one equation to the next. Now, once you do your substitution, you have to solve for whichever variable remains. So for example, if the two variables you had were x and y, if the first thing you did was you simplified down to solve for x, then when you substitute that in, the only variable left would be y. So pay close attention to what you're doing, keep track of your variables as they become very important as you go on. Now once you've solved, that becomes the indication of your solution type. It's going to be during this second step here that is going to determine if you have one solution, infinite, or no solution. Okay, so it's going to be this second step. Essentially, what's going to happen in the second step is you're either going to find a value for your variable, meaning y equals 3. That's going to indicate that you have a one solution system. If you find an answer for this variable here, you have a one solution system. The other thing that might happen is your variable totally disappears and you're left with a true statement, meaning you get something like 4 equals 4. That means that you have infinite solutions. If you end up with a true statement, you have infinite solutions. The other thing that could happen is a false statement. For example, 6 does not equal 12, or 6 does not equal 13. It's probably a better visual. So here, that would mean no solution. So if you get a false statement, that's no solution. The only reason you would move on to steps 3 and 4 is if you have a one solution system. If you find infinitely many or no solutions, then essentially you are done, and all you need to do is classify your system from there. However, if you find that you have a one solution system, then to finish out says that you need to substitute what you just found back into one of the original equations to get its other solution. Okay. Now, it is always a really smart idea to double check your solutions to verify that they really were true solutions by plug and chugging them into your system and checking to make sure that that solution does in fact work. Okay. So what I wanted to do is I wanted to show you an example, or a couple examples, so that you can see how this method actually works. Alright, so here we have solve the system using the substitution method, and this is the system that we have been given. So here, the first thing that you need to do is you need to choose which equation to start with. Now, I'll be honest, if I was sitting in front of all of you in person, I would be asking you to tell me which equation you want to use. Obviously, that's kind of hard to do. And so here, I would just go ahead and do what most students do. We'll start with the top one. So we're going to choose 2x minus y equals 2. Again, normally I would ask my class which variable you want to solve for. However, most students generally choose x. So we're going to go ahead and solve for x. So this is what we're going to look for. So here that means we need to move the y and get x by itself. So we get that x is going to be, to move the y, since it's already subtracted, we got to add, and we need to divide by 2. So this becomes 1/2 y plus 1. Notice 2 divided by 2. So I've solved for a variable. I solved for x. That's your first step. Your second step says that you have to substitute it into the equation that you did not use. So we're going to substitute it into the 4x plus y equals 3. So what that means is that this part of my equation here has to become the x value. So this becomes 4 times what I solve for. So this is that 1/2 y plus 1. And then plus y equals 3. So what we have to do here is we have to simplify completely. So we're going to go ahead and distribute my value in. 4 times 1/2 is going to give me 2y. 4 times 1, so plus 4, plus y equals 3. I need to combine my terms. 2y plus y gives me a 3y. And then I need to take this 4 and I'm going to move it to the other side. Because it is being added, to move says I have to subtract. So 3 minus 4 is a -1. Get y by itself. So here we have that y equals -1/3. So this was that second step I was telling you, where this step determines the type of solution we have. So what you need to notice about this step right here is that we did find a value for y. So automatically we already know, so here we know this is a one solution system, which means we can actually take a minute and classify it because we know it is a one solution system. If you remember your classification, so if we look, one solution is going to be consistent and independent. So we would go ahead and be able to write that one solution system here is going to be consistent and independent. Now this doesn't mean that we're done. It just means that we already knew what solution we were looking for. In order to finish, we now have to solve for the other missing variable, which means we have to continue on to step 3, which says we have to take what we just found and we need to sub back into your original first equation. So that would be the 2x minus y equals 2. So in other words, you're going to solve in to wherever you started. So here we had solved for y, so we got to substitute for y. So this becomes 2x minus, this was a negative 1/3, equals 2. Minus a negative becomes positive, so this is 2x plus 1/3 equals 2. Now to make life easy, I'd get rid of the fraction. So I'm going to multiply this whole thing by that denominator. That does say that I have to multiply through to all 3 pieces. So 3 times 2 gives me a 6x. 3 times a third is plus 1. 3 times 2 gives me 6. I need to move this 1 over. So this becomes a 6x equals 5. And to get x by itself, we get 5, 6. So here's the second solution. Now, to actually write your solution as a true solution, your system solution is going to be a coordinate point at the point 5/6 and negative 1/3. So this would be the correct answer to your problem. Okay, so that is solved by substitution, and in this case we had a one solution system. Alright, now this problem again says we're going to solve by substitution. Now this one specifically is my favorite one, and I really like when I am in front of a classroom to be able to pretend like I am a student on a test. In other words, one of you, and I like to solve this as if I was a student. So what I usually say is to sit back, relax, put your pencils down, and just watch for a minute. And see what happens, because this is a really cool system, but a lot of students on the exam tend to get a system like this wrong. So I'm going to take a minute here. I'm going to go ahead and pretend to be a student on a test, and let's just see what happens. So, substitution method. First thing I'm going to do is choose. So I'm going to make life easy because I can't stand fractions, so I'm going to use the first one. So here again we're going to solve. And I found x. So then my second step says I need to substitute into the fraction equation, which really makes me kind of nervous here, but we'll go ahead and do it. So this becomes 1/3 times the 3y plus 6 minus y equals 2. So distribute that through. So this becomes y plus 2 minus y equals 2. So 2 equals 2. Wait a sec. Well, that doesn't look right. So let's start over again. Okay. Alright, so let's start with the other one. So I have that 1/3 x minus y equals 2. Again, I'm going to solve for x, so I've got that 1/3 x equals y plus 2. So x equals 3y plus 6. So my second step says that I need to sub into x minus the 3y equals 6. So 3y plus 6 minus 3y equals 6. So 6 equals 6. Wait, that still doesn't look right. Okay, so I have no idea how to solve this system. Hopefully I won't lose too many points on the test. And so let's just move on. So that is what I see happening most of the time when you get to a problem like this one. And then as an instructor, it just breaks my heart to watch everybody erase like crazy because you simply forgot the rules about systems and the fact that we had 3 different types of equations. So let's go ahead and take a look at this here. So what I did here is I actually wrote out both ways, so you can see solving actually both ways that I just did. When you look at the first method, again, we chose the first equation, we substituted in, and we get down 2 equals 2. Now, when I was a student, what happened was I didn't recognize that this is a true statement and actually has a definition. A true statement is infinitely many. So this problem was originally done correctly until I erased. When I erased, I did it this second way because, let's face it, what do we all do when we're students? If we think that we did it wrong the first way, then we'll try it the other way before totally giving up. Now, if at any point in this problem, so on this page, I had just simply left the work that I had shown and then not done anything else, I would have received, say, most credit on the problem. The only thing I would not have received credit for is actually stating my solution here to be infinitely many. So if you're talking about, say, a 5 or 6 point problem, showing just this amount of work, those first 2 steps that we did without erasing it, would have been worth, say, 5 out of those 6 points. So if you notice, so both of these methods gave you that true statement here. So this is actually infinitely many. Well, here's the trick. Take a close look at this system. If I were to take this first equation and get rid of the fraction here, I would have to multiply everything by 3. So notice when I do that, I get x minus 3y equals 6. Now, look at my second equation. They are exactly the same identical lines. And what we know is that identical lines mean infinitely many. This is one of those special cases that we have. So do pay close attention. They do show up. These special cases are some of my favorite problems, just because they've got this really cool aspect to them when you solve. Now, the other special case, remember, would be a false statement. So if you solve down like this and you get a false statement here, that doesn't mean you did it wrong. What it means is that you would have no solution. Alright, so that is, in a nutshell, everything you need to know to kind of get started with doing systems of equations using the substitution method. I hope you enjoyed it. So if you have any questions, please let me know. Otherwise, be sure to have fun, try very hard not to use your eraser, and I'll see you next time.